So how does a hydrogen engine work? Powered with electric motors, hydrogen fuel cell cars are also known as e-cars. The common abbreviation is FCEV, short for Fuel Cell Electric Vehicle, in contrast to a BEV, or Battery Electric Vehicle. One main difference between electric cars and hydrogen cars is the source of electricity. While electric cars run on batteries charged electrically, hydrogen cars produce their own electricity, as they have their little power plant on board. This power plant is the fuel cell. First comes air. The FCEV's front intake grills deliver the outside air to the fuel cell system, which makes electricity. Hydrogen travels from the tanks to the fuel cell system. In the fuel cell system, hydrogen and oxygen from the air combine in a chemical reaction that creates electricity to power the vehicle, moving you forward. When you put your foot on the accelerator, electricity from the fuel cell system is sent to the motor, leaving nothing but water. In the end, the only byproduct of creating electricity with hydrogen and oxygen in our fuel cell system is water, which leaves through a hatch located on the bottom of the Mirai. What is a hydrogen fuel cell? A fuel cell is an electrochemical cell that converts chemical energy of a fuel into electricity by hosting some reactions. In the fuel cell of an FCEV, or Fuel Cell Electric Vehicle, electrical energy is produced with the reaction of hydrogen and oxygen with the help of electrolysis. The advantage of combining fuel and oxygen in a cell is that you can, in theory, convert most of the chemical energy to electricity, whereas burning them, as it happens in the internal combustion engine of a car, has a maximum efficiency of about 50%. In practice, only about 25% of the chemical energy does the useful work in driving the engine. The rest comes out as waste heat. How is this electrical energy utilized? Electrical energy produced during the electrolysis process goes to either electric motor to power the FCEV directly, or to traction batteries for charging purposes, depending on the driving situation at a specific time, while water leaves the system as water vapor. Traction batteries are smaller and lighter than the batteries used in electric cars. Like other e-cars, hydrogen vehicles can also recover or recuperate braking energy. The electric motor converts the car's kinetic energy back into electrical energy and feeds it into the backup battery. Let's look at some of the advantages and disadvantages of hydrogen-powered cars for users. The pros and cons of a particular propulsion technology can be seen from two main perspectives, that of the user and that of the environment. First, hydrogen as an energy source is very promising. For example, hydrogen in itself is an energy storage medium, storing energy in the form of gas or liquid. This stored energy will never dissipate until it is used. This is unlike batteries and capacitors, which can lose their stored energy over time, even without use. Though hydrogen molecules usually require a lot of resources to annex, however, the fact remains that it's a renewable energy source that is bountifully and infinitely available. Also, unlike fossil fuel combustion engines, the byproduct of the combustion of hydrogen in fuel cells include energy, water, and heat. No greenhouse gas is produced, making hydrogen clean, non-toxic, and safe for all components of our planet. Besides, hydrogen energy is 3 times more potent than gasoline and other fossil-based sources of fuel. This means that you need less hydrogen to complete an enormous task. This is why hydrogen is commonly used as fuel for spaceships. A vehicle that utilizes hydrogen energy will travel more miles for almost 300 miles with full hydrogen tanks than one that uses electric battery. Also, vehicles that use hydrogen take between 3 to 4 minutes to refill, while those that use battery take between 30 minutes to 12 hours to refill. That's a lot of time to spare. Moreover, hydrogen cars have pure electrical propulsion, resulting in virtually no engine noise at all. Despite all these advantages, hydrogen energy has its disadvantages. The biggest disadvantage of this technology is the non-availability of refueling stations. Special fuel pumps for these cars are as low as 41 in the United States, compared to 80 in Germany. Low numbers of on-road hydrogen vehicles don't encourage operators to establish special refuel pumps. The irony is, the few fueling stations are a major reason for less hydrogen cars on roads. Chicken and egg problem, right? BMW's homeland of Germany leads the way in terms of finding a solution. They have joined a program with hydrogen producers and operators to expand the hydrogen fueling station network to 130 stations in the next 3 years, fueling up 60,000 cars in Germany. The next target is to establish 400 stations by 2025. Now, let's talk about the cost. The other reason we see less hydrogen cars on the road is the price. For example, in terms of range and distance, FCEV tends to perform better than BEV. The more expensive mass-produced electric cars that tend to offer battery ranges of about 300 miles is the Tesla Model 3 long range that has a range of 322 miles with a price tag of $40,000. On the other hand, the hydrogen-powered Hyundai Nexo comes with a real-world range of 414 miles with a price tag of $59,000. So in terms of range alone, hydrogen vehicles have the upper hand. In addition to less industrialized production, these cars are expensive because platinum is used as a catalyst during the power generation. As the metal is expensive, manufacturers are trying to reduce its need to reduce the total cost of a hydrogen car. The cost will be the same to that of the electric cars once the desired platinum reduction is observed in manufacturing. Operating costs is yet another reason in slow mass adoption of these cars. On average, hydrogen fuel prices $13.9 per kilogram, while gasoline prices are around $2.44 per gallon. Hydrogen cars use an average of 0.8 kilograms of hydrogen per 100 kilometers, while petrol cars use around 1.5 gallons of petrol per 100 kilometers. So, if you spend $70 to get 5 kilograms of hydrogen and $40 to get 16 gallons of petrol, a hydrogen car will only travel a distance of 625 kilometers, while a petrol-powered vehicle can go as far as 1,090 kilometers. That's a huge difference. However, NREL estimates that hydrogen fuel prices may fall to the $10 to $8 per kilogram range in the 2020 to 2025 period. Could be reduced significantly. Let's delve a bit more into safety requirements. Global Technical Regulation Number 13 is an agreement between Japan, Europe, and North America that sets the safety requirements that all high-pressure hydrogen systems must adhere to. Compliance with this regulation is tough and requires hydrogen tanks to be dropped, frozen, damaged, exposed to chemicals, hydraulically and pneumatically cycled, stuck on a bonfire, and ultimately burst to ensure tank performance throughout the lifetime of the vehicle. Therefore, engineers have worked to ensure that hydrogen tanks are designed not to leak. The new multi-patented carbon fiber-wrapped polymer-lined tanks are built in a 3-layer structure and absorb 5 times the crash energy of steel. In a high-speed collision, sensors stop the flow of hydrogen. To prevent hydrogen from traveling to potentially damaged systems outside of the tank, the system is designed to automatically shut off the tank's hydrogen output valve. Any leaked hydrogen is quickly dispersed. All hydrogen-related parts are located outside the cabin and are designed to help prevent leaked hydrogen from building up. Toyota even tested their carbon fiber tank by shooting it with a .50 caliber round. The tank didn't explode, it simply released hydrogen safely into the atmosphere. Since hydrogen is lighter than air, it rapidly disperses, reducing the time to cause damage in the event of an ignition. Hydrogen is arguably safer than gasoline, so safety isn't a huge concern for hydrogen, which is good for FCEVs. How well distributed are FCEVs as of present? Well, if you live in California, there's a chance you might have come across one FCEV before. There are nearly 8,363 of them currently on California roads. The Low Carbon Fuel Standards, LCFS, Hydrogen Refueling Infrastructure, HRI, credit provisions took effect, predicated on the goal of reaching 200 hydrogen stations by 2025. The 4 California stations are the first of a series of stations intended by Iwatani for deployment in the western part of the United States. Current auto manufacturer provided projections for on-the-road FCEVs are 26,900 in 2022 and 48,000 in 2025. Today's network of 41 open hydrogen fueling stations has established the early fueling market that enabled the launch of the FCEV consumer market in California. Of the 24 funded stations currently under construction, 11 are projected to open later this year. So that ends this topic. I hope you have been able to gain something new today about hydrogen cars and fuel cell technology.